morning to one person here. Myself Raja S, working as Assistant Professor, EC Department, SNS College of Technology, an autonomous institution Coimbatore. In this YouTube video, I am going to discuss about 23 ITT 301 microcontroller and embedded system under Unit 4 Design and Integration of Embedded System for the topic Introduction to Embedded System. As these IT students, they already know about what is meant by microcontroller, how they are used in real-time applications, and now this is the introduction of embedded system. Now we are going to see what is meant by embedded system. An embedded system is a computational system that is developed based on an integration of both hardware and software in order to perform a given task. It can be said to as a dedicated computer system has been developed for some particular reasons. But it is not our traditional computer system or general purpose computers. These are the embedded systems that may work independently or attached to a larger system to work on a few specific functions. These embedded systems can work without human intervention or with little human intervention. That is, it may be a automatic or it may be a semi-automatic. So now I am going to discuss the introduction to embedded system. As you see, this embedded system is used mainly in everyday devices like smartphones, and also it can be used in the healthcare devices like monitoring of our human pulses, ECG, EMG, and MRI, CT scan, and also it is mainly used in industry for robotics, that is movement of objects from one place to another place. Finally, it also uses some real world challenges like user can be specific in terms of automation. Automation means how the speed is displayed and how that maintain the accuracy and how the efficiency is calculated and what kind of power efficiencies here we need to calculate. So these are this introduction to embedded system. As you are the student to know about how this embedded system is applicable in design thinking approach, first we start with why embedded system. That is, every day we are using smartphones, smartwatches, Bluetooth speakers, Bluetooth headset, as that both they attached with the hardware and also with the software. So how they are working? As you see the industry case study, robotics and automotive vehicles are used in both hardware and software migration, and in healthcare we can use pacemakers and monitoring devices as an embedded system, and all this will create a user demand for speed, efficiency, and low power calculations. Next we switch on to the next phase, that is called define. So as you know, the problems are clearly identified. We have to find the how to improve the efficiency of embedded system. That is, we can increase the power efficiency, we can increase the real-time operation, and the system need to be upgradability in all over the condition, and either they have maintained a small kind of application or a large kind of application, and cost wise how it is maintained, whether it is a low cost, high cost, and how we can manage the power. That is, for longer work period, if take very small power, then the power efficiency would be a greater one for supporting an embedded systems. Next, ideate. Once you identify by modifying some internal components, how can the power efficiency can be varied? That is, by using this core component, we can modify the component by using a microcontroller or processor, and sometimes we can use the memory as a read-only memory, random access memory, or a flash memory, and sometimes we can use the input-output interfaces such as sensors and actuators. In this, sensor is the input devices, actuator is output devices. For example, if you want to measure any temperature in a room, the temperature measurement sensor is called as a input sensor, and if the sensor is measured the temperature, depend upon the sensor temperature. If you want to switch on the fan, that fan can be rotated, the switches can be on by using the actuators. Next, the hardware and software can be connected with the name called software, that is real-time operating system, and firmware. Finally, these communications are controlled either in online or offline by using UART, Universal Asynchronous Receiver Transmitter, serial port interface, and CAN-based optimization control. Next, prototype. Once all these phases are completed, then we must design some new innovative product by using a hardware basis. For example, here the input is taken as the motion sensor, then the processing control unit we have used ARM processor, Arduino processor, or PIC microcontroller. Then based on this, the output can be indicated as a light sensor. Suppose for a person is entering to any area, automatically this light will be displayed on. So once this will be displayed, the same control can be sent to the user controlled mobile interface, or it can be controlled by a software based interface. Next, this is the evaluation matrix. Once we find out the product, we have to test and we have to find how these are working. That is by considering reliability, accuracy, efficiency, safety and cost. All these parameters are very important to calculate any electronic product which is designed by the embedded systems. So this is the mind map that is used if you are a student to recollect whatever we are studying. Then these are the puzzles that I have planned. Once regular class I will discuss. Then based on this, our students are taking their seminar. Already this is one kind of teaching pedagogy method we are applied. Then these are the references that I included for my reference. If you want to know anything, you may click this and you can get the reference whatever I prepared. Finally, thank you for watching my video. In this YouTube video, I discussed what is in by embedded system, what are the core components of embedded system, how this introduction to embedded system are discussed on design thinking phase. Next YouTube video, I will bring with a new innovative topic. Thank you for watching my video.